So now that we've learned what a derivative is and how to find a derivative, we can look at some applications. So we'll look at three different word problems. The first one is going to be a 5-year projection of population trends suggests that T years after 2010, the population of a certain community will be P thousand, and then it gives you the formula, the function, okay, of the population. Now there are two key things here that you really need to pay attention. First of all, T is the years after 2010, and P is in thousands. All right, this will be important. Always pay attention to how it's measured. Okay, the first one. At what average rate will the population be growing between 2010 and 2012? So remember that average rate, you do not need the derivative, right? Average rate is just what we learned from before. So it's going to be, we use our regular function, our P of T that's already given. Now, in 2010, T is equal to 0 because T is the years after 2010. And in 2012, T is equal to 2. So what we're going to have here is we're going to have the average rate, so part A, is going to be P of 2 minus P of 0 over 2 minus 0. And then you plug in, right? So just be careful. It's going to be negative 6 times 2 squared plus 12 times 2 plus 151 minus, and then you get to plug in 0. So that will be 0 plus 151 over 2 minus 0, which is 2. Here the 151s are going to cancel. You can do the math right there. Negative 6 times 4 will be negative 24 plus 24 divided by 2. But that's going to give us 0 over 2, which is 0. So the average rate of the population change was 0. That doesn't mean that the population never changed. It means that the average rate was 0. So for example, what could have happened is it grew in the first year from 2010 to 2011, and then it decreased. And so then the average rate would be 0. Or it could have decreased, and then it could have increased. So what we're going to see next is we're going to calculate what's happening in 2012. We're going to find the instantaneous rate in 2012. So add t equals 2. And then we're going to be able to tell, well, in 2012, specifically in 2012, is the population growing or is the population not growing? So to do instantaneous, right, the rate of change, and remember, it didn't even have to say instantaneous. It could have just said rate of change, and we assume that it's instantaneous. We have to find the derivative. So we have to do the limit as h approaches 0 of f of x plus h minus f of x divided by h. This is going to give us the limit as h approaches 0. Oops. And you can do f of x plus h on your own on the side. You should get negative 6x squared minus 12xh minus 6h squared plus 12x plus 12h plus 151 minus your f of x, negative 6t. Oops, I should have used t here. I used x. Apologies. Minus 6t plus 12t plus 151 over h. And as we saw previously, some of the things here cancels, right? So the negative 6t squared, this will become a positive 6t squared. Then you will have the plus t, and this will become a negative 12 when you distribute the negative. And the 151 with the negative 151 will cancel. So I'm going to be left with the limit as h approaches 0 of negative 12th minus 6h squared plus 12h over h. And this becomes the limit as h approaches 0. Everything has an h at the top, so negative 12t minus 6h plus 12. And when I plug in h, the limit, which I can because now it's a polynomial, I get negative 12t plus 12. And this is my f prime of t, or I should say p prime of t for population. So if I want to find the instantaneous rate of change in 2012, which is at t equals 0, I just need to plug in p prime of 2. And this is going to give me negative 12 times 2 plus 12. And so this is going to give me negative 24 plus 12. So it's going to give me negative 12. So what does this mean? Remember that p is measured in thousands. So that means that in 2012, the population is decreasing. How do I know it's decreasing? Because it's negative at a rate of 12,000 people. Okay, so the community is losing people in 2012. So it is decreasing at a rate of 12,000 in 2012. Okay, let's do another one. Okay, now we're looking at sales. So a company's total sales in millions of dollars, again, remember it's important to look at how it's measured. T months, so now T is in months, from now, are given by the following function. Find S prime of T. Okay, so we need to do the derivative. So S prime of T is going to equal to the limit as H approaches 0 of S T plus H minus S of T over H. And again, I know I just keep writing the formula over and over. It helps. So this is going to give me the limit as H approaches 0 of the square root of T plus H plus 4 minus the square root of T plus 4 over H. The 4's will cancel. I'm going to be left with, I'm going to come down here because I know I'm going to need some room. The limit as H goes to 0 of the square root of T plus H minus the square root of T over H. Now remember, my goal there right now is to plug in 0 for H, which I cannot. So what I'm going to do, because I have radicals, is to multiply by the conjugate, which you did for limits already. So I'm going to multiply by the conjugate, which is T plus H plus the square root of T. But what I do to the top, I must do to the bottom. Now remember that when you multiply by conjugates, which we did for limits, I'll do it here on the side, if you have a plus b times a minus b, it becomes a squared minus b squared, right? The middle terms cancel out. So I'm going to have the square root of t plus h times the square root of t plus h, which is just t plus h. And I'll have a minus the square root of t times the square root of t, which is just t. And at the bottom, I won't multiply out, and I forgot to write the limit. So imagine. And this is going to give me the limit as h approaches 0 of h over h square root of t plus h plus the square root of t. Exactly what we want to happen happens. The h is canceled. So I'll have that this is equal to the limit as h approaches 0 of 1 over the square root of t plus h plus the square root of t. Now you can plug in 0. So I'll have 1 over the square root of t plus the square root of t, which will be 1 over 2 square root of t. And this will be s prime of t. Okay, perfect. We have our derivative. Part 2. Find s of 9 and s prime of 9. So s of 9 means that I'm using the regular function, the original. So that's going to be the square root of 9 plus 4, which will be 7. What does this mean? Well, look at what S is. S is a company's total sale in millions of dollars, T months from now. So 9 months from now, the company's total sale will be $7 million. Okay, that's what that means. So 9 months from now, company's total sales will be $7 million. S prime of 9 will be the rate at which the sales are changing. So this is going to give me 1 over 2 square root of 9, which is going to give me 1/6. So 9 months from now, the total sales is changing at a rate of 1/6 million. Okay, and if you wanted to, right, you could get this into a decimal, and so it will give you approximately 0.17. So it's changing at about 0.17 million. Okay, part C, it says, use this result from part B to estimate the total sale after 10 months. So you can use it together. If you know that 9 months from now, the total sale is 7 million, and you know that it's changing at a rate of 0.17 million, that means that 10 months from now, it will be changing at 7 with a rate of change of 0.17, so $7.17 million. And 11 months from now, to estimate if the rate was to stay the same, which probably it wouldn't, it might change, but it would be approximately, right? You're just estimating 7.3 million. So because you know how much it was 9 months from now and you know the rate that it's changing in, then you can find the 10 and 11. And again, you're just estimating because you're not for sure that it's that because you're just using the rate of change. And of course, the rate of change can also change, right? We know that the slope is not constant if it's a curve. And in this case, square root of t plus 4 is definitely a curve. Okay, let's try one more. Okay, Susan Lee, the owner of Susan Lee Sunglasses, estimates that when a particular pair of sunglasses is priced at P dollars per sunglasses, she will sell. Okay, so P right here is the price. And then it gives you the total cost per month of this. It says first, express Susan's profit as a function of the price. So A, profit. Now profit is revenue minus cost, right? Whatever it costs you to do something, you have to take that out from how much money you made, and that will be your profit. Now revenue is the price you're selling it at times how many you're selling of whatever you may be selling, right? So if you're selling 10 t-shirts at $5, you made a revenue of $50. However, your cost is you had to obtain the shirts. So you have to take that out from your profit. So here it gives you the price. It tells you that the price is P squared minus 7P. So first we're going to find the revenue. R of P is going to be how many we're selling. So, right, estimate that when a particular price at P dollars per sunglasses, she will sell. So we have, since we know that the price P per sunglasses, she's selling right now this many, P squared minus 7P. The price is P, and she's selling P squared minus 7P. So this is the amount, and this is how many she's selling. So that's going to be P cubed minus 7P squared. The cost is given to you. So you have P of P is going to give us, the revenue, P cubed minus 7P squared, minus, use parentheses, 0.3P squared plus 4P plus 300. Distribute the negative, minus 0.3P squared minus 4P minus 300. Combine like terms, and it's going to give us P cubed minus 7.3P squared minus 4P minus 300. Okay, looks good. Okay, so here's our profit function. Okay, we haven't yet done any calculus. We just figured out the profits. Okay, now here it comes. At what rate, keyword rate, we need to find the derivative. Is the profit changing with respect to P when the price is $50? Okay, so our price is going to be $50, part B. We want to know the rate, so we're going to find the derivative. Now, this right here, it looks a little complicated to use the whole difference quotient. So what you're going to learn next is how to find the derivative using some tricks, using some differentiation rules. So without using the definition of the derivative, and something you're going to learn next, I'm going to find the derivative, and then you'll see how I'm able to do it so quickly afterwards. So derivative is going to be 3P squared minus 14.6P minus 4. So normally you would have to do the limit as h approaches 0 of P plus h minus P of P divided by h. And here I didn't have to do that, and I was able to find this very quickly. So you'll see how to do that next. Okay, so now I need to plug in 50. P prime of 50 It's going to give us 3 times 50 squared minus 14.6 times 50 minus 4. So 50 squared is going to give us 2,500 times 3 will give us 7,500 minus 14.6 times 50, going to give us 730 minus 4. And when you combine all of those together, it's going to give us negative 7,666. So that's the rate at which the profit is changing when Susan is pricing the sunglasses at $50. This is really bad. This is not good for her company. Okay. Why? Because the next part is asking you, is the profit increasing or decreasing? The profit is decreasing because it is negative. So she needs to change something. She might be getting her sunglasses for way too much money and selling them at too low of a cost, and her overhead costs are too much. You never know, right? Maybe the retail store she's renting, the lease is too high. Okay, something like this. But right now, her company is not doing well because at $50, her sunglasses, she's losing profit. Okay,